My name is Torgeir. I'm a machine learning development team lead at KSAT. We are partners in visual intelligence, and looking through the number of participants here, I can recognize quite a few. So going to just briefly thank the organizers both of this session and for the NLDL, and commend them on how you handled the recent restrictions here. So let's see. So starting out with the how and why of deep learning at KSAT. We are a company which does several things, one of which is to provide near real-time maritime situational awareness services. So I want to have an example of detecting vessels and icebergs in the high north. So the first stage is to detect objects at sea. So these are huge Sentinel-1 radar images. You can see Bjørnøya at the bottom of the full image. It's inverted north-south, but the point still stands. These are around 60,000 times 25,000 pixels, or 1 gigapixel. So finding, yes, and each pixel represents 10 by 10 meters. So finding objects can be challenging, but it's not the most challenging automation deep learning task. However, we are able to narrow the number of mistakes down to around 1 mistake per 2 images in the test set, meaning that we can provide surveillance of 150,000 square kilometers for each detection mistake we have. So as the next stage, we can discriminate whether a given detection is an iceberg or vessel, and we are able to do this with 90% precision recall. And this was actually for an even more coarse resolution. Combining these two, we now have set the 2 radar channels as red and blue to provide additional information. I'm not going to go into the radar details here, but the essence of it is that we were able to detect 9 out of 10 objects, and then classify everything which was correctly, which was detected. Looking at the false alarm, we can see a slight peak in the red channel, and our experts tell me that's the predominant channel for icebergs. So they actually considered that this might have been a small iceberg that they missed. And the detected and missed vessels show how the sensitivity of the deep learning algorithm is. So these are 100 by 100 croppings from 60,000 by 250,000 image. So this is truly a needle in a haystack. You're looking for a few pixels in a sea of around 1 billion pixels. So this was quite encouraging for us. But why? Why do we need to automate it? We have humans doing this job now. And the answer is very simple. So we have a 24/7 staffing for manual service, or should I say partly manual service, because there is an automated sort of step in it, and they perform corrections. But given the future amount of data that we will receive, we need to do most or all fully automated. And there's also the expectation that the cost must not scale with the amount of data. So even though we could staff up to having 20 persons around the clock, logistically, the cost would not be as our customers expect. And that's only natural, as deep learning has provided computer vision with opportunities that previously were unheard of. So how does research come into this? We have had some lessons learned. Some were through mistakes, or not mistakes, but things we will do differently next time. And some were through successes, which is also very important to learn from. So, number one, getting started is not a research problem. So deep learning, as of now, there are tons and tons of companies doing things and solutions out there. The frameworks are much more mature than they were a few years ago, and I'm not just talking about TensorFlow and PyTorch, but everything to put it into production. And productionalizing it is likely a more difficult task for any industry starting with this. When you have a collaboration, agree explicitly on the deliverables. Are you expecting a working system which you can put into production? Are you expecting a model? If so, what are the interfaces and formats of the model? Or are you expecting a report? We've had successful collaborations where the only deliverable was to have a proof of concept. That can be immensely valuable because then you don't have to do that yourself as an industry. And a recommendation is to work very closely together. So given that you're not in a getting started situation, you likely will have a platform on which your data scientists operate already. Let the researchers in and work on the same platform. That's how you get good communication and how you get results which are most similar to what you're doing in-house. And don't fool yourself by saying we can circumvent this by just talking often, having weekly meetings, etc., etc. That's just not how it works. There is no substitute for that. So coding skills are important. I would rather collaborate with a good researcher with good coding skills than a great researcher with decent coding skills. And that goes a bit to the point of the deliverables. What's the quality? How easy is it to understand? How sort of well documented is the history? What was done when things worked optimally, etc., etc. And I think even for a research project, which is not, except those which are very short-lived, the research projects in isolation would benefit from the rigor of good coding practices. So, what do I think research collaboration can provide for the industry? Like, what can you do for me, which is obviously one of the questions self-centered organizations can ask. Well, I think researchers can help you get the final few percentages of performance. So if you have a 90% solution, which is well implemented and put into use, definitely getting some experts in can help, especially as those experts come with a new perspective. They have a whole different way to think, and they often take the long-term approach. So that's one of the key things we are enthusiastic about with visual intelligence, is that instead of our sort of weekly or monthly focus and pace, the researchers will come in and have a multi-year approach to the problems we want them to solve. And that's all I really had. So just want to thank all of you for showing up, and I'm looking forward to the panel discussion later.